Hello students, let us continue with chapter 12 electricity. So today we will start with back exercise of this chapter. So first question is an MCQ. I am going to read it. First 4 questions are MCQs. So I'll read the first question. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is, there are 4 options given. I'll read the question again and then I'll read the options. A piece of wire of resistance R. So consider this is a piece of wire having resistance R. It is cut into 5 equal parts. So here I have shown that let L be the original length. So this is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is. So what I have done here, this resistance, let its length be L. This is a piece of wire, let us say having length L and resistance R. If this is cut into 5 equal parts, then length of each part will be L by 5. And we know that resistance R is directly proportional to length of the wire or the conductor. So in this case, L by 5 will have resistance R by 5. Okay, so L by 5 has resistance R by 5. And in the question it is mentioned that if all these parts are connected in parallel, let R dash be the equivalent resistance and you have to find the ratio R by R dash, where R is the original resistance of the complete length of the wire and R dash is the equivalent resistance of the parallel combination of these 5 parts from the same length of the wire. So here we'll use the formula for parallel combination and find R dash first, because we know that R dash is given by this expression 1 by R dash is equal to 1 by R by 5 plus 1 by R by 5 plus 1 by R by 5. This way you have to add the reciprocals. You know why we have taken R by 5? Because it is the resistance of each part and these 5 parts are connected in parallel. And hence the equivalent resistance of these 5 resistances or 5 parts of wire is given by R dash, which is given by this formula. So after simplification, we can show that 1 over R dash is 25 by R. But in the question, what are the options given? The options are given for which expression? R by R dash. So from this, 1 by R dash is 25 by R. In the question, it is given that R by R dash is equal to, there are 4 options given. So we will take R to the other side. In this case, we get the answer R by R dash as 25. So we know the answer is 25. And in the options, they have given 1 over 25, 1 over 5, 5 and 25. So our option is D option, which is 25 is the correct answer. Now I'll read the second question, second MCQ. Which of the following terms does not represent electrical power in a circuit? So very simple. You have to answer out of the 4 options given, which I have written here, which does not represent electrical power in a circuit. We know electrical power P is given by P is equal to VI. You know this formula. And using Ohm's law, that is V is equal to IR, using the mathematical expression of Ohm's law, we can easily show that P is equal to VI is also equal to I square R is also equal to V square over R. Here we have just used the formula V is equal to IR and we have got these 3 expressions. And so from the given expressions I square R, IR square, VI, V square over R, you can easily answer which expression which does not represent electrical power, IR square. So B option is the answer for our second question, that IR square does not represent electrical power and all the remaining 3 expressions express electrical power. Now the third question is, an electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volts, the power consumed will be, there are 4 options given here. So I'll read the question again, and I have not written options on the board. We will actually solve it out. An electric bulb is rated 220 volts and 100 watt. It means potential difference when V is 220 volt, power P will be 100 watt. Okay. Then you have to find when it is operated on 110 volts, the power consumed will be. So let us represent this new potential difference by V dash. So when V dash is 110 volts, you have to find the power consumed. So let us represent it by P dash. Now, as we can see in the above question, we have three different expressions for power. So in this case, we will use the expression P is equal to V square over R. As the same component, same electric bulb is operated here also in this case. Okay, so the resistance of the bulb or bulb filament will be same. So we can use this formula where resistance is constant. So P is V square over R. So we can find the resistance by using this formula. R is equal to V square over P. Either we can find the resistance and then find the value of P dash by using this formula. P dash is V dash square over R. V dash is given. R you can calculate it from that expression. Okay, and put the values and get the answer here as 25 watts. But what I have done, I have not found out the value of R. I have instead substituted here P dash is V dash square over R. For R, I have put V square upon P. So after simplifying this, we get this V dash square upon V square into P. So V dash over V I have taken common. I mean inside the bracket, square I have removed out. So V dash over V whole square into P. Put the values of V dash, V and P, and after doing simplification you get the answer as 25 watts. So there are four options given: 100 watt, 75 watt, 50 watt and 25 watt. So the correct answer will be D, which is 25 watt. Now the fourth question, I'll read it and we'll see what will be the correct answer. Two conducting wires of the same material and of same lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations would be. Now the fourth question is, two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations would be. Now students, as the two conducting wires are of the same material, same length and equal diameters, it means resistance of each wire will be same, because resistance formula is rho L over A. So they have is equal length, equal diameter means equal cross-sectional area. Same material means resistivity is same. We know resistance is given by formula R is rho L over A, and we can easily see that both the conducting wires will have the same resistance. So let us write, let R be the resistance of each wire. We know that potential difference will, keeping potential difference same, they are first connected in series and then in parallel. So let RS represent the equivalent resistance of the series combination of the two wires and RP represent the equivalent resistance of parallel combination of these two wires, each having resistance R. So by using the simple formula for RS is R1 plus R2. Here R1 and R2 both are same, so they are each equal to R. So we can write is equal to R plus R. So RS is 2R. This is, let us, there's no need to actually name this, okay, number this. Next is 1 over RP is 1 over R1 plus 1 over R2, but we know each of these two, R1, R2 is equal to R. So we can put instead of R1, R2, R, and we get 1 over RP is 1 plus 1, 2 by R. Therefore, RP is R by 2. As I've told you, there is no need to, number these two equations. Now, what is the next given? That keeping the potential difference same. The two wires are first connected in series and then connected in parallel. What you have to find is ratio of heat produced in series and parallel combination. So let HS represent heat produced in series combination and HP represents heat produced in parallel combination. Since the potential difference is constant in both the cases, so we are using this formula. We know there are three formulae for H. H is equal to I square RT, H is equal to V square over R, and S is equal to VIT. Here we will use the formula V square over R. H is V square over R because V is constant in both the cases. So this formula will be better. So HS is V square over RS and HP is V square over RP. So this we should number this as 1 and 2. These two equations as 1 and 2. In the question, we have to find the ratio of heat produced when they are connected in series to the heat produced when they are connected in parallel. So, dividing 1 by 2, we get HS by HP is equal to, just put this V square over RS divided by V square over RP. So, when we simplify this, V square gets cancelled. We are left with RP over RS. And now putting the values of RS and RP, we get RP is R by 2 and RS is 2R. After simplifying, we get this is 1 by 4 or 1 is to 4. So we have got this answer, and in the question there are 4 options given. 1 is to 2, 2 is to 1, 1 is to 4, 4 is to 1. So C option, which is 1 is to 4, okay, ratio of 1 to 4 is the correct option in this question. Now, the fifth question is, how is a voltmeter connected in the circuit to measure the potential difference between 2 points? And I hope, students, that you know the answer. We know that voltmeter is always connected in parallel across the points between which the potential difference is to be measured. As we can remember that ammeter is always connected in series in the circuit where the current is to be measured, and voltmeter is always connected in parallel across the points or across a device across which the potential difference is to be measured. Okay, so now I'll read the 6th question. It's a numerical. A copper wire has diameter 0.5 millimeter and resistivity of 1.6 into 10 raised to minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? How much does the resistance change if the diameter is doubled? So you should now write what is given. A copper wire has diameter 0.5 millimeter. So d, small d, we can write it is 0.5 millimeter. Okay. And we know it, and resistivity of 1.6 into 10 raised to minus 8 ohm meter. So resistivity is represented by rho. Rho is 1.6 into 10 raised to minus 8 ohm meter. What will be the length of this wire to make its resistance of 10 ohms? It means if we take capital R as 10 ohms, you have to find the length. And next is, how much does the resistance change if the diameter is doubled? So if diameter is doubled, it means if the new diameter is represented by d dash, and if d dash is 2 into d, diameter is doubled, what will be the new resistance? R dash. How would it change? The question is, how would the resistance change? The question is not what will be the new resistance. Okay. So what we can do is, first of all, see if any conversion is required. Yes, this millimeter should be converted into meter first. So diameter, you can convert it into meters as you know how to convert it. Okay. And here I have found R is equal to d by 2. Radius is d by 2. So you can find the radius, or you can use the formula for d only. For area, you can use d in the formula as you wish. So now resistance formula R is rho L over A, and we know cross sectional area of any wire is circular in shape. So rho L over pi R square. Either you can write R square, or as I have told you, instead of R you can write d by 2 whole square because R is d by 2. So as you wish, you can proceed. and after putting the values of all the things which are given, only L is not given, which you have to find out. You can do the simplification and get the answer as 122.7 meters. So this is the length of the copper wire required with these dimensions and this material so as to make resistance of 10 ohms. Now question is, how would the resistance change if the diameter is doubled? Okay, so we know that if we write this R in terms of diameter, we can proceed this way. R is rho L over A, area is pi R square, and R is D by 2, as I have told you there. So you can write this expression after simplifying as resistance is 4 rho L over pi D square. This is when D is a diameter. So let us say if D dash is 2D, resistance is R dash. So R dash will be equal to 4 rho L upon pi D dash square, which is now 2D whole square. Material is same, length is same, only diameter is doubled. So we can write here 2D whole square. And when you simplify it, you can keep 4 rho L over pi D square separate. 4 rho L over pi D square separate. And we can put R for this. Okay. And you get R dash is, don't cancel this 4 here. Okay, because you need to substitute for R here. Actually, you want some expression here, something which can be substituted by R. So 4 rho L over pi D square should not be, simplified here. So keep it same. This represents R. So we can show that R dash becomes 1 by 4 times the original resistance. Now, even if you finish till here, you will get full marks because the answer is how would the resistance change if you double the diameter. You can write it till here and write the answer that the resistance would become 1 by 4 times the original resistance if the diameter is doubled. But I have proceeded further also. In case the question is find the value of the new resistance if the diameter is doubled, then you can put the value for R, which we know is 10 ohms, and we can find it out as 2.5 ohms. So this is a new resistance. It is 1 by 4th of the original value. I hope the questions that we have discussed today, which includes the MCQs and numericals, are clear to you. So we'll continue with the back exercise of this chapter in the next video. So thank you, students.